The International Space Station is a straight-up engineering masterpiece, the biggest thing we've ever built in space. It's a prime example of what's possible when the world collaborates. So, let's break down the ISS and see what's going on under the hood. The ISS has been orbiting Earth since 1998, and it's been continuously manned since 2000. Now, the ISS sits in low Earth orbit, around 400 kilometers up. Why that height? Well, at this altitude, the aerodynamic drag is high enough that the breeze doesn't stick around for too long, reducing the risk of something hitting the station. But that also means more frequent boosts from the propulsion system are necessary to keep it in place. The ISS circuits the Earth about 16 times a day. 5 space agencies keep the ISS running: NASA, ESA, Japan's JAXA, Canada's CSA, and Russia's Roscosmos. And together, they've secured operations through 2030. Now, let's break down the ISS itself. It's 109 meters long and 73 meters wide, with a mass of 419 tons. The station can house up to 7 crew members at a time. Let's get into how the ISS stays operational up there. Cargo resupply missions from Earth are handled by spacecrafts like SpaceX Cargo Dragon and soon the Dream Chaser spaceplane. And the crew transport, that's currently managed by Crew Dragon, Russia's Soyuz, and soon Boeing's Starliner. The docking system, which was a collaborative effort by all 5 space agencies, was rolled out in 2010. Each docking port has an internal diameter of 0.8 meters for crew and cargo transfer. It is also equipped with connections for power, data, air, and communication. Docking happens in 2 phases: soft capture and hard capture. During soft capture, 6 servo-actuated legs stabilize the spacecraft, removing any relative motion. Then comes the hard capture, where 12 pairs of mechanical hooks latch onto the capsule, securing it in place. Let's talk about power. The ISS runs on 120 volts or 28 volts. The higher voltage lets them use smaller conductors, which save space and weight, critical in space operations. Half of the energy generated by the solar panels is stored in lithium-ion batteries, which is crucial for the 35-minute eclipse period in each orbit, when the station isn't getting sunlight. These batteries are mounted outside the station on the truss structure, which frees up space inside but makes maintenance a bit trickier. The ISS has several clusters of solar panels. The main set includes 4 pairs of panels to track the sun to optimize energy production. Each array covers 375 square meters and produces between 80 to 120 kilowatts of power at 180 volts. There's also a smaller Russian array that generates 5 kilowatts of power at 28 volts and can be rotated as well. Lastly, there's the roll-out array. These are flexible and 30% lighter than the main arrays, taking up only a quarter of the volume of the main panels but delivering the same performance. Next up, we have thermal management. The ISS has 10 radiators to dissipate up to 70 kilowatts of heat each orbit, which comes from sunlight, onboard electronics, scientific experiments, and even the crew. To efficiently radiate the heat, the radiators use ammonia, which is toxic. To keep the crew safe, all the ammonia-based systems are located outside the station. 2 external, independent ammonia coolant loops run through these radiators. Inside, there are 2 water cooling loops, one for low temperature and one for medium temperature. The connection between the external and internal loops are 5 heat exchangers. The main radiator cluster consists of 2 assemblies, each with 3 sets of 8 radiators, covering an area of 23 by 3 meters. The secondary cluster has 4 assemblies with 7 radiators, each covering an area of 13 by 3 meters. All radiators can be deployed and retracted as needed. And of course, the ISS is primarily up there to do science. All the other systems support this mission. There are 4 main science modules: Destiny, the US lab; Columbus, the European lab; the Japanese experiment module; and Russia's multi-purpose laboratory module. Each of these modules is equipped with standardized express racks, which are modular setups for scientific payloads. These have standardized mechanical interfaces for science payloads, can be thermal controlled, have standardized power and data interfaces, and can be supplied with nitrogen or current. Altogether, there are 33 racks, each holding 10 payloads, meaning up to 330 experiments can run at once. Additionally, the ISS has external payload facilities that are fully exposed to space. These are perfect for testing materials in space conditions or studying cosmic rays, for example. It is really interesting which scientific experiments are made up there. But this is a topic for another video. Thanks for watching.